So let's look at that practically. Here I've got switch 1, switch 2, and switch 3. Switch 2 and switch 3 are connected to a hub. So that's following the topology shown in this Cisco guide. I've just booted up the switches, so you can see they're coming up at the moment. So these are brand new switches with no configuration at all. Okay, so on switch 1, I'll set the host name to switch 1. Switch 2, I'll set the host name to switch 2. You may be able to hear that my CPU is maxed out while the switches are booting up. So at the moment my GNS3 VM is at 87%, local CPU 62%, but that'll settle down in a moment, which it now has. So show spanning tree. So show spanning tree. At the moment this switch is not the root. You can see it's got a path cost to get to the root on gigabit 01. So I'm assuming that switch 3 is the root. Show spanning tree. We can see in the output here that switch 3 is the root switch of the topology. So I'll change that. I'm going to go onto switch 1 and type spanning tree VLAN 1 root. And actually I'll just set it by priority. So priority, and let's set it to 0. So show spanning tree. We can see that this switch is now the root of the spanning tree for VLAN 1. We're running rapid PVST on the switch. So some ports are still in the learning state, but there they go to forwarding. So we can see all ports on the switch are forwarding. Those are the 2 ports of interest on switch 1. On switch 2, show spanning tree. So there's the command, show spanning tree. We're running rapid spanning tree. Path cost to get to the root is 4 out of port 1, which is gigabit 00. Gigabit 00 is the root port. And notice how gigabit 01 is the alternate port on this switch. It's in the blocking state. That's what we learnt in the Cisco document. An alternate port on this switch means that there is a port on another switch that's the designated port. In other words, it has a better path to get to the root bridge. So let's look at switch 3. Show spanning tree. On switch 3, it has a path cost of 4 out of port 1, which is gigabit 00. So this is the root port of switch 3. We can see that here once again, gigabit 00 is the root port. And this output, gigabit 01, is the designated port, and gigabit 02 is the backup port. Backup port is in the blocking state. Alternate port on switch 2 is in the blocking state. So this port is blocking, this port is blocking. This is the only port that is forwarding on this segment connected to the hub. So loops will be blocked in this topology, even though we connect it to a hub. That demonstrates the port roles and status that you get in rapid spanning tree. On switch 2, once again, I'll just move this up a bit. So on switch 2, connected to the hub on gigabit 01. Gigabit 01 is an alternate port. That is the role. The status of the port is blocking. Gigabit 00 on that switch is a root port. That is the role, and the status is forwarding. On switch 3, gigabit 00, this port is the root port. It has a status of forwarding. That's the best port to use to get to the root bridge. Gigabit 01, in other words, this connection, is the designated port. The role is designated, the status is forwarding. This interface, gigabit 02, is a backup port. That is the role, the status is blocking. So, blocking or discarding, to use the industry standard term, is the state of alternate as well as backup ports. Root ports and designated ports have the forwarding status in a stable topology. A state of learning means that traffic is still being discarded on the port. So as an example,